can write also, that is fine. So it is very easy to understand, right? So it is very easy to understand because there is nothing complicated, right? Understand. It is very easy to understand, right? Right. So there is not complicated, right? So if there is an age, put it. If it is weight, then put the weight. That is as simple as that. And it is easy to implement also, right? Easy to implement. Because what if we are going to write a code, so what you will write, you will just put two for loops, right? You'll just put two for loops. Then what you will do, so then you will just simply assign the value, right? Either 0 or 1, right? You will traverse this particular graph. So how you will traverse the graph, that also we're going to teach you in subsequent class anyway. So there are BFS, DFS and all these things. But what you will do, so you will just traverse this graph and you will put 1 or 0 or else wait, or that's it, right? So depending upon whatever the value, you'll just put in the matrix. So that's what you will do. You will put two for loops, that's all. Okay. So third advantages is that it is very important. So this is with respect to time complexity. Okay. So if I'll ask you, right? So if there exists an edge from B to C, how much time complexity you will take in order to answer that? I'll repeat my question. Can anybody answer? I know you are little, I know, but can anybody answer, right? If I'll ask a question, right? What is the time complexity? Let me write the question. What is the time complexity to check if an edge exists from ith vertex to jth vertex? Can anybody tell me? I hope you know basic time complexity. Can anybody tell me? Any idea? So if I'll ask you, okay, suppose these are whether there exists a is whether there exists an is can anybody answer? Okay, Sankas says order of E. Okay. No, right? So why you need order of E, right? So you will directly check, right? So A of ij, right? So what code you will write? So if you write if A of ij equal to 0, then so your code will be like this. If A of I equal to 0, then print. Suppose print age does not exist, right? So that is what you will print. Else print there exist age, right? That is what, right? So you will directly, right? So it is a matrix. If you know it is an array or matrix, you can directly access that particular index, right? You don't need to iterate through all these vertex or edges, right? So you don't need it at all. You can directly go to that position. So if I ask you 2 to 3, there exists an S, you can go to matrix A 2 3, right? You can just retrieve it. So that's it. Then that's why it is going to be order of 1, right? The answer is going to be order of 1. That means if you want to check if there exists an A's from 0 to 1, sorry, any to I to j, then it is going to happen in a constant time, right? So that means in order of 1 time. Is it making sense? Is it clear for everyone? This is a very important point. That means if you are your efficiency, right? So if your frequent operation is just to check an edge, right, then it is very important that you can go for this. Okay, okay, good. Okay, okay. So these are the all some advantages, right? So let me write one more point, right? So this is very important point also, right? So addition, right? Can anybody say add or removal of edge of an edge? It's only one edge I want to add, or an edge takes how much time? What is the time complexity if I want to add an edge, right? Suppose B to D there does not exist an edge. I'll just add it. Suppose I will add it. I'm just giving an example. So how much time it will take? Time complexity. Can you guess? Right? Can you guess? Yeah. Okay. So it is again order of one, right? So because what you will do, you will go to this B to D, right? You will go to B to D here and you will change it to 1 or whatever the weight is present, right? So that's what you will do. And since it is a undirected graph, since B to D, D to B also you need to do. D to B, you will go here and change to 1. Or maybe suppose whatever the weight is present. Suppose weight is 1, then we will put 1, 1. Or else if it is 10, 10, then we will put it 10, 10. So then it is just a constant operation, right? So you are not doing any for loop, something like that. You are directly going it and putting it, right? So there is two changes it will happen. One change and two change. That's why it is going to be order of 1. Is it making sense? Selina, are you clear on this time complexity? I don't know means how much comfortable you are. Also Tulsi. I hope Sanket and Kalpana, you both are clear, right? Okay, that's good. Okay, so these are the some advantages, right? So of this adjacency matrix. But what are the disadvantages? Let's go back to the second one. So which is like what is the disadvantages, right? So let me erase these advantages, right? I hope you have taken the notes. Okay, so let me tell you what is the disadvantage. Now let's discuss, right? So if you'll see, so definitely I need a 4x4 matrix, right? What is the 4x4? That means the space complexity is going to be, right? Always it is going to be order of V square, right? Consumes more space. That is big of V cross V. So because size of this one is V cross V, which is equal to big of V square. Because I need a matrix. So how many number of vertex maybe? Like let's look into this, right? So let's look in this, right? That does not exist much edge, right? Only 1, 2, 3, 4 edge, right? If you look into this particular representation, this is a directed graph, that is fine, but how many edges are there? So only one represents means edge, right? So there is only 1, 2, 3, 4 edges, right? So this is also 0, 4 edges. To represent 4 edge, you still created a 4 cross 4, that means 16 entry, right? 16 entry, which is 4 cross 4, right? Only 4 edges are there, right? So this is one edge, this is one edge, this is one edge, this is one edge. There is only 4 edges are there in this particular directed graph. But still you created 16 entries, right? They are just waste of memory. Think about it. Suppose there are only 4 edges, but my hundreds vertex are there, right? 100 vertex are there. 100 vertex. then you will create a matrix of 100 cross 100, is not it? Although maybe suppose 10 entry are there, 10 edges are there in that matrix, in that graph. So in order to store only 10 edge, so 10 edge, right? You are creating a 100 cross 100, right? So which is how much? 10,000. 10,000 entry you are creating a matrix of size like, right? So which is just waste, right? Right. So in the bracket, even if you can write, so even if the graph is sparse, even if the graph is sparse, we discussed, right? What is a sparse graph? Sparse graph means less number of edges are present, right? So that's what I was giving example. Suppose there is a 100 cross 100 vertex is there, but only 10 edges are present. That means that is a sparse graph, right? But still you need a 100 cross 100. So then in that case, that is very wastage of memory, right? Very wastage of memory, because 10,000 memory you are creating, but you have only 10 edges, right? So that is just waste of memory. That is one of the important points. So another, is it clear, right? I hope you are clear, right? I hope you are clear. Just ask me if in case you have any questions. Then addition and removal, right? So addition and removal, right? Removal of a vertex takes order of v square, right? Time. So age, if I add, there is no issue. Age is faster, because age, if I am adding, that we discussed just few minutes, that is advantage. If you are adding an age, then that is advantage, right? Because you can just go ahead and change, right? B to D age means B to D, D to B, B to D, D to B, B to B, D to B. That's all. But if I add a vertex, let's talk about that. This is my graph. Let me remove this. Okay. So let me make it this one as 0. And this one is also 0. Okay, suppose I add another vertex, right? This, right? And I connect something. Although I added a vertex 1 edge, but still, what all you need to do? You need to make this 5 cross 5. That means you need to increase this and you need to increase this. There's now five vertex. Again, every entry you are going to modify definitely for here. But again, you will check. This is suppose D. D to A, D to B, is there any S? So you need to fill this V vertex, this V vertex. So that's why it is going to take order of V square. That means all the vertex you need to check, right? So if there exists an edge, you need any update, right? So that's how it is going to, like C to D, there is no edge. So you need to add. Then again, D to C, you need to add, right? Again, D to B, every vertex you will check. If there is, oh, D was already there. So let me put it as E. That's why if you are adding a vertex, new vertex, that is going to take an extra time, right? So which is V square time. So that's why this is also one of the demerit, right? Is it clear? So what are the advantages and disadvantages? So what is adjacency matrix? So what we discussed till now. So what is adjacency matrix? Definition, example with respect to directed, undirected graph, directed graph, undirected weighted graph. And I had given one assignment for you for directed weighted graph. And then we understand what is the advantages. In advantages, we discussed about some time complexity, disadvantages, and we discussed about some time complexities, time and space complexity also. So graph representation, right? So what is graph representation? So given any graph, right, how should we represent in terms of memory, right? So you want to implement some algorithm. Suppose you want to find what is the degree of this vertex. By looking into this, you know, we have already discussed about degree and all in the previous class, previous lecture. So you can check, right? So in case you have not. But if you want to find out the degree of this vertex is 3. But how you will find out? If I'll ask you write a program, right? So how you'll write the program? So that means, first of all, this graph somehow you should represent in some form, right? So after that, suppose I'm just giving an example. So you can represent in some matrix form or something like that, right? So which edge is connected to which one? Something you will maintain in that particular matrix. We'll understand in details, no need to worry. But first of all, we'll convert this one into some form, right? So there are different forms like adjacency matrix. So this is what I was talking about, adjacency matrix. Or maybe you can go for adjacency list or incident matrix or maybe list. Okay. So you can go for that kind of representation, right? So once we represent that, then you can apply the algorithm, any algorithm, right? So you can apply the algorithm. So like you are trying to find out the shortest distance from this vertex maybe to this vertex. Okay, so this vertex A to this vertex B. So first of all, you need to represent, right? So this is your first step. So if what before writing any algorithm, so you should understand how should you represent that graph in some form. This is one of the form. There are different forms. After that, you will apply the algorithm, shortest path, or you are saying, right? So you are saying that okay, like maybe degree of a vertex, whatever you want, right? Whatever question you can ask with respect to graph theory. Once you represent that one in the memory, you can just write some programs or write some algorithm, right? So that's why it is very important for us to understand if any graph is given, so how can I represent that particular graph in computer, right? So generally, right, so there are different ways generally. So what are the different ways? So one is adjacency matrix, right? Adjacency matrix, right? Adjacency matrix, right? We'll go one by one. Second one is same adjacency list, right? Right, adjacency list, or else incidents, right? Incidence matrix. Okay. Third one is incidence. Incidence matrix. Here also we'll see if the list is there. Okay. So this is the thing, right? So this is the list, right? So these are the major three types of representation that happens. There are can be different representation also we can think of depending upon your requirement, right? But anyway, so these are the major three types of graph representation. So let's understand one by one. So let's understand one by one. So let's make a heading adjacency matrix. Okay. So let's make a heading which is adjacency matrix. Okay. So let's make a heading. So let's make a heading adjacency matrix. Okay. So what is adjacency matrix, right? So adjacency matrix means, so given any particular graph, okay, so we need to convert that one into some matrix form, right? That's what you understood, right? So, so what we are going to discuss. So as part of this, we'll understand first, right? Adjacency matrix. So we'll understanding and example and time complexity, then advantage, then disadvantages. Okay. So these are this is the agenda for everything, right? So every graph representation. So we'll first understand. So we'll take some example and we'll understand and we'll write down the definition and all. And after that, we'll understand. So when to use or what is the advantages of time, complexity, type, and space. You can write type and space. Okay, both we'll study. And then what is the advantages of using this and what is the disadvantages of using this, right? So these are the major things we are going to discuss. Okay. So before going for definition and all, so let's first understand, right? So what is this adjacency matrix, right? Okay. So what is this adjacency matrix? So given any particular graph, right? So suppose let me take on any graph, right? So let me take on a graph, right? So let me take on graph. Suppose let me take here. Suppose this is my graph, maybe of 4 vertex. Let me take 4 vertex. Okay. Suppose this is A, B, C, D. Okay, suppose this is my 4 vertex. Okay. So what does the adjacency matrix says? Create a matrix. So if there are 4 vertex, so what will be my matrix size? It will be 4 cross 4. Okay. So I'll write down all the definition, but just let's try to understand. So if since this particular vertex, this particular graph contains 4 vertex, how many vertex are there? 4 vertex. right? So this is GV. So V, so 4 vertex means V is 4, right? V equal to 4, right? So if V is 4, so then the matrix I need to create is V cross V. That means 4 cross 4 in this particular example. In this particular example, it is 4 cross 4. Okay. So this is a 4 cross 4. So you can take this A, B, C, D in this side, A, B, C, D in this side. Okay. So what this adjacency matrix contains? It contains either 0, right? Any of the, right? Suppose this matrix name is A. So then A of Ij, right? Either 0 or 1. So I hope now you might be guessing. So when it will be 0? 0 means no edge. No edge between, I'll write down all the definition between I to J. I means there exists an edge between I to J, right? So this is very straightforward, right? So if there exists an edge from D to B, you will go to D and B, you will put a 1. If there does not exist any edge between Ij, then you will put 0. If there exists an edge, then you will put it to 1. So that is as simple as that. So let's actually complete this example. Suppose this is A to A, so definitely there is no self loop, so I can put it 0, right? A to B, okay, whether there is any edge, yes, A to B there is an edge, then you can put it 1. A to C, there is any edge? No direct edge, there is a path, but I'm talking about there is edge, if there is a edge. A to C, there is no edge. A to D, yes, there is a edge. B to A, B to A, B to A, yes, this is an undirected graph, then there exists a edge, okay. Then B to B, that is 0, this you can put 0, 0, 0, 0. B to C, B to C you can put at 1. B to D, you can put it as 1. Okay. Then C to D, C to A, there does not exist any S, right? C to B is there is a H. C to D, C to C there is no S. C to D there is a H. D to A, there is a H, there is an S. D to B there is an H. D to C there is an H. D to D there is no S. So this is my adjacency matrix, right? So this is known as adjacency matrix for a undirected graph, right? So this is an undirected graph, right? We'll go for directed graph example also, but this is what the adjacency matrix. We'll write down the definition, but I hope it is making sense, right? So basically what this you are creating a matrix, right? It's giving a graph, so you are just converting this graph into this particular matrix. What does this particular graph matrix contain? It just contain either 0 or 1. When it will contain 0? If there does not exist any edge. When it will contain 1? If there exists an edge between I and j. So if I look into this particular one, what does this one represent? So if I'll ask you, what does this one represent? This one represents there is an edge from C to D. That means whatever the graph is, but there definitely, if you look into C to D, there must be an edge. Yes, there is an edge, right? So any particular one you will take, so that means that is represents an edge in that particular graph, right? So that is what is all about the adjacency matrix. Okay, so let's write down some of the definition, right? So definition, so that you will get clarity. Okay, so let's write down some definition. And adjacency matrix is a 2D array of size what, right? So an adjacency matrix is a 2D array, right, of size V cross V, right? Like I told, right? So of size V cross V. Okay. So what is V? Where V is the vertex, where V is the vertex set, right? Is the number of vertex, is the number of vertex in graph G. So if this is the graph, right? So this is the graph G, VE, right? So that is what the representation. So V is how much? 4, right? So example, so you can write example. So V equal to 4 in this example, particular example. So adjacency matrix size matrix size is 4 cross 4. You can see. So this is 4 cross 4. right? So this is first point, right? So this is the definition, right? So uh, so this, right? So any particular entry, right? So in the matrix, both rows and represents. So what are these rows? What does this column or rows represent? So these are the vertex, like I told, right? So this is going to be A, B, C, D, A, B, C, D, right? So that's what you can write in this particular matrix. So both rows and column represent a vertex, right? Both rows and columns represents vertices, right? Vertices. That's right? So okay. So any entry, right? The matrix, the any entry in the matrix is either 0 and 1, right? Any entry in the matrix is either 0 or 1 if there exists. So you can write, right? So I don't write. So 0 means if there exists edge. 0 means 0 represents if no edge. No edge. 1 means there exists an edge. So in mathematical form, so how can you write adjacency matrix? Means if there is a given any particular graph, so this is a 4 vertex, right? How many vertex? A, B, C, D. 4 vertex are there. So then I am generating a 4 cross 4 matrix, right? 4 cross 4 matrix, right? This is my 4 cross 4 matrix. I created it. So this is also ABCD and this is also ABCD. Row column represents ABCD. So what does this entry represents? It represents either 0 or 1, right? So as simple as that. It represents either 0 or it keeps either 0 or 1, right? So that's why it comes. Sorry, it keeps. Okay. So what does that 0 means? 0 means, suppose let's talk about this 0 or maybe this 0, right? So this 0. Okay. So that this 0 represents there does not exist an edge from C to A. C to A, that does not exist an edge. If you look into C to A, there is an edge? No, there is no edge. If I add this, then there will be an edge, right? So this means 0. 0 means there does not exist an edge, right? So no edge, right? So if you look into that, 0 means no edge between that pair of vertices. 1 means C to B, 1. What does that mean? C to B, there must be an edge. Go to C to B, there is an edge. Okay. So there is an edge. Okay. So that is what this particular. So let's read this. An adjacency matrix is a two-dimensional array of size V cross V, where V is the number of vertices in the graph G. Okay. So okay. So example V is 4. So adjacency. So if there is a graph is given of size 4, then what will be my matrix size? My matrix size will be V cross V or 4 cross 4. In this example, 4 cross 4. Okay. So that is what I was trying to say. Okay. So both rows and columns represent the vertices. If you look into the rows A, B, C, D, columns also A, B, C, D. Okay. So that is what any entry. So what does this 1 or 0 represent? So either it represents 0 or 1. 0 means no edge. 1 means there is an edge. So how it is represented? Suppose this is my matrix A, right? So A of ij equal to 0. 0 means no edge between I and j, ij, right? Suppose CB, right? CB, there is an edge. CB, if you look into, there is an edge. So that's why it is 1. Okay. So if there is an edge, so then there is an entry 1. If there is no edge, then it keeps 0. So either it contains 0 or 1. If there is an edge, then 0. Sorry, there is an edge, then it is 1. Or if there is no edge, then it is 0. As simple as that. Is it clear for undirected graph, right? So this is an undirected. I'll go for that particular. I think Sanket has asked for to explain that one. But let's me first make it clear on undirected graph. Is it clear undirected graph? Can you just type clear if you're clear on directed graph, or in case you have any questions, just let me know. Okay. Sanketa is clear, Kalpana is clear, Selna is clear. How about Tulsi, you? Are you clear? Okay, so not sure. They'll say you have an internet issue. But anyway, so let's go back to this directed graph, right? So if I'm coming to directed graph, right? So this is an example of classical example of directed graph. So what is a directed graph, right? Directed graph means so whenever there exists an edge, right? So whenever there exists an edge from B to A, that does not mean that there exists an edge from B to A, sorry, A to B. So here, I hope it is pretty straightforward, right? So directed, so this is my undirected. So if this is my X to Y, so this means there exists an edge from, there exists a path from X to Y. That means you can go from X to Y, you can come back from Y to X. But if I write this X to Y, so this means you can go from X to Y, but you cannot go from Y to X. There does not exist. Y to X is not possible, right? It is not possible. Y to X, because there does not exist an edge, right? So then again, this formula holds for same thing. If there exists this matrix, again the same thing, right? So there is nothing difference. But if you understand this directed graph concept, then you are done. So you need to check whether there exists an edge. So A2, right? So A2, so if you ask me A2, so how many edges exist from A2? A to D, there exists only one edge, right? So that's why if you look into this, A to D, there is a one, right? Whether there exists an edge from A to B, no, there does not exist, because this edge is from B to A. So it is starting from B to A, not from A to B. So that's why this is not one, right? Rather than it is zero. A to B, there does not exist one edge, right? A to B, there is no edge. So that's why that is zero, not one. Okay. A to D, yes, yeah, because it is going from outwards, right? A to D, yes, this is edge. So that's why A to D there is an edge. Others are zero. There is no edge from A. So same, right? For B, what are the edge? B to A there is an edge. B to C there is an edge. B to A there is an edge. B to C there is an edge. Others are zero, right? And same goes on, right? So if I'll ask you C, from C any edge is going? No, all are incoming edges. So C is not connected to anyone. From C, can you go to anywhere? No, there is no edge. There is no path. So there is nothing. You can, because this is a one direction. Try to understand. This is not bidirectional edges, right? This is a directed graph. So that's why C, you cannot go anywhere, right? So that's why C is all zeros. If you look into this, C is all zeros, right? So D, from D, you can go to C and no other edge. So that's why D2 you can go to C, right? So that's why this is one. Is it clear now? Can you type clear if you are clear with the directed graph, right? If you are clear with the directed graph. Okay, that's good. That's good. Okay, so let's move on, right? So let's move on. So if I'll ask one more question, right? So let me modify this question, right? So you can make another example. Don't modify. You create one more graph, okay? Or else let me erase this, okay? So suppose I am creating a new example, but this is, we discussed about the directed graph, we discussed about the undirected graph. Same. We are still in the adjacency matrix. So, but if an weighted graph is there, right? Suppose now let me ask you same question for weighted graph. Suppose there is an weighted graph is there. Same question, right? Suppose weighted graph means A, B, C, D. But this time I'll put some weight 10, 25, this is 25, 35, something like this. So now this is a undirected graph, and also there is a weight available to that particular, right? So then what will happen? So then how your this adjacency matrix will be represented, right? Again, since there are four matrix, so this is going to be 4 cross 4, right? So there is no change, right? So then let me draw it as 4 cross 4. Now it is 4 cross 4. Okay. Okay. So then again, this is going to represent vertex, right? So because the definition says that this is going to represent both rows and columns represent vertex ABCD, ABCD. Okay. So how about the entry, right? So here there will be a little change, right? Earlier either it is 0 or 1, but this time, because earlier the all the edges has had actually weight 1, right? Because if there exists an edge, every edge is considered as same. But here the same rule principle apply, but there is a change, right? So this 0 or this is going to be weight, right? Instead of 1, this is going to be weight of ij, right? That is the change. Weight of ij. What does that means? Let's understand. So a is connected 0. Let me put these 0 0. They are not connected. There is no self loop. A is connected to B. Yes, A is connected to B. But this time, try to understand very focusedly. This time, I'm not going to put 1. Rather than I'll put 10, right? Because there is an edge from A to B of weight 10, right? So that's why A to B is 10, right? Okay. So A to C. So how much I should put? A to C. A to C is connected. Then it is 5 also. And A to D, yes, this is 35. So B to A, yes, they are connected 10. B to C, yeah, B to C is also connected 20. B to D is not connected, that's why 0. C to A, if you'll actually for finding C to A, since you calculated A, if you don't need to go to mark this particular thing, you can directly go to A to C. What is there? 5. I don't need to see this now. Once I calculate for B, I need to calculate B to C. C to B, let me see, go to B to C, and it is just the same thing, right? B to C is equal to same C to B, right? Because it is an undirected graph. B to C is equal to C to B, right? So that's why C to D, but D to C you have not calculated. I need to go to here. C to D. C to D is connected. Yes, this is going to be 35. So D to A. D to A means A to D 35. D to B means B to D 0. D to C means C to D, which is 35, and this is 0. So this is my adjacency matrix. Okay, and this is a weighted undirected graph, right? So remember this is a weighted undirected graph, right? Weighted undirected graph, right? Okay, so this is the weighted undirected graph. So I hope you can find. So if I make this one as weighted directed graph, I hope you can create this, right? So same thing, same logic will be applicable. You can take this example, put some weights and try to figure out by yourself. So there is nothing going to be much. So this is all about the adjacency matrix. So why we discuss what we discussed, right? So basically, okay, C to D is 25. Okay, C to D is okay. That is 25. Yeah, C to D is 25. That's correct. My mistake. Yes. Okay. Yeah. D to C also will be 25 because I calculated from there. Yeah. Sorry. Okay. Yeah.